All right, in this video we're going to look at converting parabolas from general to vertex form. And this is revisiting our section on writing quadratic expressions going from general to standard form. And in many courses, you'll learn a technique known as completing the square to solve the problems that we're going to look at. However, we're going to use the techniques from quadratic expressions to get the same result. So if you hear or see the phrase completing the square, that's what we're going to be doing essentially here. So example 3, write each of the following in vertex form. We have y equals negative 1/4 x squared plus 5x minus 24. We've talked about how to do this algebraically, where we take negative b and divide it by 2 times a to get the x coordinate of the vertex, and then plug the x coordinate of the vertex into the expression to get the y coordinate. And that's all well and good. However, we also have technology to help us out. So here is our parabola for example 3a. Gonna have to move over a little bit, and our vertex is at 10, 1. So our vertex is at 10, 1. The value of a that's in our general form is going to be the same value of a that's in our vertex form, so negative 1/4. So we have everything we need, so we can write y equals negative 1/4 times the expression x minus 10 in parentheses squared, and then plus 1. Now the nice thing is we can check to see if that's right by seeing if we get the exact same graph. So negative 1/4 times x minus 10 in parentheses squared, and then plus 1, we do get the exact same graph. And that's true for just about almost all rewriting equations. Is if you start with graph your original equation and then graph the equation you came up with, if they're the same equation, or the same graph rather, then chances are you did not make a calculation error along the way. So that's always comforting to know that you can at least check your answers there. All right, part B, we have y equals negative x squared minus 4x minus 14. The vertex here, if we go ahead and graph part B, I'm going to have to gotta zoom out a little bit more. There we go, way down here. Our vertex is at negative 2, negative 10. So this time our vertex, negative 2, negative 10. The value of a is negative 1. So our equation becomes y equals negative, or negative 1, times x plus 2 in parentheses squared, and then minus 10. So remember, it's always x minus h. In this case, x minus negative 2 becomes x plus 2. So again, y equals negative, the expression x plus 2 in parentheses squared, and then minus 10. All right, part C, x equals 1/2 y squared plus 7y plus 41 halves. Let's find the vertex here. And here we get a vertex of negative 4, negative 7. So here our vertex is negative 4, negative 7. Now if we want to do this one algebraically, it's negative b over 2a, so negative 7 over 2 times a half is 1. That'll actually give us the y coordinate of our vertex, and then we plug that value into this expression to get the x coordinate. So when we switch our x and our y, we essentially also switch our h and k as well. That'll come into play in the next couple videos, so more info on that later. Our value of a is a half, so our equation becomes x equals 1/2 times y minus a negative 7 becomes y plus 7 in parentheses squared, and then minus 4, or plus a negative 4. So we get x equals 1/2 times the expression y plus 7 in parentheses squared, and then minus 4. All right, part D, we have x equals negative y squared minus 2y plus 9. So let's see that one. And okay, don't have to adjust it. This time our vertex is at 10, negative 1. So vertex at 10, negative 1. Our value of a is negative 1. So it becomes x equals negative the expression y plus 1 in parentheses squared, and then plus 10. Again, if we wanted to graph this answer, it should match the graph of the original, and we'd know that we're good to go. All right, so that about does it for this video. Thank you for watching, and I'll see you next time.